At a depth of 11,000 meters, this is the most terrifying place on Earth, and also its deepest point. Here, even sunlight is crushed into nothingness, and ordinary life struggles to survive. The pressure is over 1.0 times that at the surface, strong enough to flatten steel like paper. Fewer people have visited this place than have walked on the moon. When the observation window of the Trieste suddenly cracked in 1960, the lethal fangs of this mysterious realm were fully exposed. What kind of deadly traps lie hidden in this deep sea 10 times more dangerous than a moon landing? Why does this oceanic abyss, discovered 150 years ago, have the power to swallow tectonic plates and crush submarines? And how can such an extreme environment nurture a life that defies our understanding? This is the Mariana Trench. Today, we will follow the blood-stained path of exploration to uncover the deadly truths and geological mysteries of the Mariana Trench. In 1875, a British Royal Navy research vessel, named the HMS Challenger, embarked on a global expedition. Their mission was to conduct the first ever mapping of the global seafloor. The crew measured depth using ropes weighted with lead, traveling from the tropics to the poles. After hundreds of measurements, they assumed the seafloor was a flat expanse of silt, at a depth of 3,000 to 4,000 meters. But when the ship reached a point 2,000 kilometers east of the Philippines, something eerie happened. The lead weight sank 3,000 meters without hitting bottom, and continued to fall at 4,000 and 5,000 meters. In an era without advanced navigation, the crew kept splicing ropes together, while terrified by legends of deep-sea monsters. It was said that giant tentacles would emerge from the darkness to drag the entire ship into the abyss. When the lead finally hit bottom at 8,000 meters, the most terrifying trench in human history had been discovered. Little did they know, had they steered just a little further west, they would have found the Challenger deep at 11,000 meters. What does 11,000 meters actually mean? If you were to drop Mount Everest into this trench, its peak would still be submerged under 2,000 meters of water. This is the true navel of the Earth. This arc-shaped canyon, 500 kilometers long and 70 kilometers wide, could easily contain 5 Grand Canyons. Even more bizarrely, it is still growing. The root of all this lies in the life and death struggle of Earth's tectonic plates. You might ask, how could such a deep crack appear on the seafloor? This begins with the puzzle of Earth's crust. You can imagine the plates on Earth's surface as icebergs floating on magma. The Pacific Plate acts like an ancient geological conveyor belt, carrying 170 million years of history as it drifts westward. When it encounters the younger Philippine Plate, the denser Pacific Plate is forced deep into the mantle. This violent compression and collision formed this profound trench. How terrifying is this force? It not only created the trench, but also gave rise to the Ring of Fire. 90% of the world's earthquakes originate here. The seafloor constantly spews liquid carbon dioxide and molten sulfur, and there are even mud volcanoes 50 kilometers in diameter, releasing hydrogen gas. These spectacles are extremely rare in our solar system, but compared to geological hazards, the pressure of the deep sea is the deadliest killer. In a swimming pool, we feel ear pain at just 3 meters deep, but at the bottom of the trench, the water pressure is 1,100 times that at sea level. That is equivalent to 1.1 tons of weight per square centimeter. If you were dropped down there, it would be like having 50 Boeing 747s pressing down on your body. Even specially designed submersibles have frequently met with disaster, yet some dared to challenge the Grim Reaper. In 1960, US Navy Lieutenant Don Walsh and Swiss scientist Jacques Piccard boarded the bathyscaphe Trieste to begin the first manned deep-sea dive. When the vessel reached a depth of 9,000 meters, a sudden, loud bang echoed through the cabin. The two men didn't think much of it at the time and continued their descent for another 3,000 meters. It was only upon reaching the seafloor that they discovered the outer plexiglass observation window had cracked. This was their final line of defense against the crushing water pressure. If the hull cracked even a little more, they would be instantly crushed into pulp. Through a 50mm observation port, they witnessed a sight they would never forget. In the darkness, something was moving. At first, they thought it was a flatfish, but later they realized it was a sea cucumber capable of surviving in extreme environments. After just 20 minutes, they made a hasty ascent. And this feat would not be repeated for the next half-century. Why is deep-sea exploration harder than landing on the moon? During the same period, nearly 7,000 people climbed Mount Everest and 12 people set foot on the moon. Yet, as for visiting the Challenger Deep, it wasn't until 2012 that a third person arrived. Renowned director James Cameron piloted the deep-sea Challenger solo, becoming the first person to reach the deepest point on Earth alone. Since then, humanity has conducted over 20 deep-sea dives. Even so, the number of visitors still hasn't surpassed those who have walked on the moon. Yet, in this forbidden zone for life, resilient miracles of life are hidden. As we follow a submersible on its descent, we experience a fantastic journey from light into darkness. The first 200 meters below the surface is the euphotic zone, where sunlight is abundant. Phytoplankton here produce half of Earth's oxygen, while tuna and flying fish thrive, forming the foundation of the marine food chain. But once we cross the 200-meter threshold, the light begins to fade, and the water temperature drops sharply. We have entered the twilight zone. The total biomass of fish here may exceed that of all other ocean regions combined. Among them, the most numerous are the 7 to 8 centimeter long bristlemouths, numbering in the quadrillions. They rely on faint bioluminescence to find food. Descending to 1,000 meters, we enter the midnight zone of eternal darkness. The water temperature stabilizes at 4 degrees Celsius, and the pressure reaches the limits of a nuclear submarine. But the darkness is not lonely. The anglerfish hangs a glowing lure above its head, waiting for prey to fall into its trap. The barrel-eye fish has upward-pointing eyes, allowing it to ambush prey from below at a depth of 2,500 meters. And the giant squid, a behemoth of the deep, can reach lengths of 13 meters, with eyes larger than a basketball. To this day, no one knows the limits of its size. Even more bizarre is the phenomenon of deep-sea gigantism. Amphipods are only a few millimeters long in shallow waters, but in the deep sea, they can grow to 30 centimeters. Single-celled foraminifera can actually grow to 20 centimeters, larger than a soccer ball, remaining perfectly fine in the high-pressure environment. When we descend to 8,000 meters, we enter the Hadal zone. The water temperature is near freezing. What allows life to survive here? The answer defies conventional wisdom. They either rely on the small amount of organic detritus sinking from the surface, or on microorganisms that process hydrogen sulfide from volcanic vents, obtaining energy through chemosynthesis, which then serves as food for other organisms. Translucent sea pigs crawl along the seabed in groups, searching for anything edible. The Mariana snailfish, as the deepest dwelling fish known to science, can swim freely at a depth of 10,000 meters. Their body structures have evolved to the extreme, with bones as thin as paper and muscles as soft as gel, allowing them to withstand the immense pressure. Yet, even so, humanity's understanding of the deep sea remains pitifully small. To date, only 400 species have been discovered in the Hadal zone, while a typical freshwater lake contains thousands of species. Our exploration of the deep sea is like shining a flashlight a few times in the pitch-black Grand Canyon and thinking we have seen the whole picture. Could those undiscovered creatures be even larger than the giant squid? At the bottom of the trenches, could the secrets of the origin of life on Earth be hidden? After all, the environment of deep-sea hydrothermal vents is remarkably similar to the ancient Earth. Perhaps the first life forms were born right here. And even more chilling to think about is, the Mariana Trench is not eternal. As tectonic plates shift, it will eventually be consumed by the mantle, and the Earth will give birth to new abysses. From its accidental discovery a century ago to the sophisticated technological exploration of today, though humanity still knows little about the deep sea, our quest for discovery has never ceased. For within those dark abysses lies the history of our planet, and perhaps the future of humanity. Good night. Thanks for watching. If you enjoyed this journey through science, don't forget to like, subscribe, and share this video. See you in the next exploration with Quantara Atlas.